Good morning, everybody. So I've already been introduced, but yeah, my name is Degioanni. I'm CTO and founder at Sysdig. I spent the last 20 years essentially doing visibility, security, and open source. In particular, yeah, I've been involved in packet capture and networking for quite a long time in my career, including being one of the original contributors to Wireshark, the open source network analyzer. I work for Sysdig. Sysdig offers a platform to run containerized slash Kubernetes infrastructures in production. We offer essentially data platform that can cover security, monitoring, visibility, troubleshooting, and many other aspects of the life cycle of containerized infrastructures. What I would like to do in the next about 30 minutes is talk a little bit about moving to Kubernetes, moving to cloud native as an enterprise from the point of view of somebody like me that is essentially in touch on a daily basis with people, especially enterprises, since Sysdig, works with enterprises of a certain scale. So somebody like me that is working with enterprises that are at different levels of this journey, essentially on a daily basis. I travel a lot, I meet a lot of people, and one of the most important things that I do in my job is essentially listening to them and try to learn from them. So I will talk a little bit about the what, so what's happening, why it's happening, and maybe a little bit about some lessons that I learned or some observations based on these conversations. So every enterprise is a software enterprise. I mean, it's pretty clear that every sector, nowadays, even sectors that are relatively traditional, sees players that are really, in the business nowadays of writing software, Even if you're manufacturing something, in practice, very much nowadays, you're writing software, you need to, run this software at scale, and this software that you write is largely the best way to compete with your competitors, or if you don't innovate quickly enough, is the best way to be outcompeted by your competitors. So this is not a surprise. People say software is eating the world. I think everybody agrees on that. Software is more and more becoming containers, right? This is just a Gartner statistic, but we're seeing more and more containerized workloads being deployed by the enterprise. Again, at different stages. Somebody's just starting experimenting with this. Somebody, we see, in some cases, massive deployments in production, but more and more software is becoming containers. And this transition to containers to run our infrastructures is clearly accelerating. So, for example, IDC is seeing, a 14x growth in number of containers running in production between 2017 and 2020. Not only the speed of adoption is fast and is growing, but adoption is also clearly evolving. The way we are treating our containers, the way we're using them is evolving. Again, I've been exposed to the containers ecosystem essentially from the very beginning, from when .cloud became Docker. And very much, in the early years, 2014, 2015, the rationale behind using container was being able to pack more computation inside a single machine, right? Being able to have more density and largely using containers and treating containers as lightweight virtual machines, right? Then this evolved into leveraging the fact that containers allow you to write software that is very portable, to making them the base for CI/CD, right? They are a very nice unit of packaging for software that can run on your laptop, can run on your test infrastructure, and then can run in production essentially in a consistent and versioned way. And then, of course, there's the wave that is still very much ongoing of cloud native, right? So using containers as building blocks for microservice-based infrastructures, largely through an orchestrator, which nowadays is largely more and more Kubernetes, right? And from this point of view, while I was flying here to Barcelona, I just went to Google Trends, and I typed DockerCon and KubeCon, just to get an idea, of the ramp of the two different conferences, mostly because, yeah, it's interesting. DockerCon has always been more about just, containers and Docker, while KubeCon is more like, about microservices, right? And the trend is actually very interesting. The red in this chart is DockerCon, and as you can see, it exploded much sooner in, 2015, 2014, 2015, DockerCon was already pretty big, while KubeCon is the blue one here, and it's more like a constant linear ramp. And you can see, essentially the two phases that I'm talking about in the first slide, right? DockerCon is more like, the left two in this slide. KubeCon is more like this, or at least it's a proxy, right? And you can see that the blue line is growing pretty linearly, and now it's become bigger than the red line, while the red line has sort of plateaued a little bit, right? So I think that this chart shows quite nicely, essentially, the trend that we're seeing in the industry and that I was describing in the previous slide. So we can say that, this slide is a visual representation of this one. So what's happening exactly, and what's driving this? The fact that, Kubernetes, containers and Kubernetes are becoming one of the de facto ways to write, run, and deploy our software is pretty clear and pretty evident, right? There are many drivers, of course, right? So in my opinion, technology is just a catalyst here, right? So Docker and Kubernetes just happen to be, two technologies that fit pretty well the needs of that drive this transition. But the real needs, the real drivers, in my opinion, are density, speed, autoscale, and multi-cloud. Again, there's more. I'm not saying that this is all of it, but this is the ones that I see the most when I talk to people. So let's go through them. Density is the one that I was mentioning before. So the ability to pack more computation inside a single machine. These, of course, has immediate economic implications in terms of cost reduction, both on-prem and in the cloud. So this is a trend that I'm really seeing. People really sort of, the single machine is becoming what was the rack before, right? And the single machine, I see now very often customers that have 48, 64 core machines, and then they pack hundreds, sometimes 300, 400, 500 containers into a single machine. So in your data center, you can just buy very fat machines and then let Kubernetes essentially use this hardware in the best possible way. But even in the cloud, very often, one of the problems is you're paying a high cost and you have a bunch of maybe instances that are not really fully utilized for what you're paying them for, right? You can buy small instances, you can have more granularity, but it doesn't work very well. While if you have an orchestrator like Kubernetes, typically you can leverage this computation in a more efficient way, and again, you cut cost, right? So the density driver is essentially a cost-based driver. Second driver is speed. Especially, this is developer-related, right? Containers, cloud native, Kubernetes make developers more efficient by offering an opinionated, well-constructed pipeline which is service-oriented, CI/CD based, consistent, and better included. Of course, the benefits here are efficiency, writing essentially better software, faster, ideally. Third driver, autoscale. I'm seeing this one especially in verticals that require to have infrastructures that expand and shrink pretty reactively. I don't know yet. A very good example is Game of Thrones last night. Clearly, the HBO website had to expand pretty quickly and pretty dramatically to sustain the load, right? So verticals like media, like retail, like financial, like television and cable companies, this is where I saw, the initial deployments of Kubernetes at scale, on maybe hundreds or thousands or tens of thousands of nodes, and yeah, companies in the television space, company in the media space, for sure, among the first ones. Already 2016, 2017, I was seeing, substantial deployments of Kubernetes. Banking and financial is another pretty clear one. Of course, the benefits here are performance. Virtual machines like cloud also makes a point of supporting elastic workloads, right? AWS was born for that reason, but containers and an orchestrator like Kubernetes are a much better primitive, when you want to do auto-scaling than a virtual machine that in any case still takes, at best, minutes to be provisioned, while a container can really do it in seconds, right? So the way you do it with containers and Kubernetes is allows you to have much better performance, and of course have infrastructures that are much more resilient by being able essentially to, as people say, self-heal through an orchestrator like Kubernetes. Fourth driver is multi-cloud. The move to the cloud is, at this point, a given. I don't think in the last 18 months I've spoken to any enterprise in any industry, in any vertical, even very conservative ones, that are not telling me we're migrating to the cloud everything or most of what we're doing. Even companies that maybe have huge data center footprints, everybody's at least thinking how to move to the cloud. So the question is not anymore, is the enterprise going to the cloud? The answer is clearly yes. The question is how they're doing it, right? And very much many organizations are looking into Kubernetes as a way to go to the cloud. Why? Mostly because I see a lot of people that would like to have the ability to run their workloads on multiple clouds for several reasons, but clearly the main one is the main ones are, number one, people want to be able to take advantage of the best features of every possible cloud, including in your own data center. But also people tend to be pretty nervous about being locked in by a cloud vendor, right? The cloud is great, and you have all of these nice features that are all designed essentially to lock you in, to make it very hard for you to move to a different cloud. And Kubernetes is very often considered as an option to create a layer maybe on top of the cloud so that it's easier to write an application that is more portable from cloud to cloud, and of course can potentially run in your data center as well, or parts of it can run in your own data center. From the cloud wars dynamic, this is definitely something that has been pushed aggressively by Google first and Microsoft as well. If you think about that, in a situation when there's a big incumbent, like in the cloud market, where AWS is, by far the leading vendor, the wannabe vendors definitely benefit by something that decreases the friction of people going from one cloud to the other cloud. So Google and Microsoft were the first ones to enthusiastically accept and push Kubernetes. Amazon was a little bit late, especially because originally they had plans to have their own orchestration methodology with ECS. But more and more, Amazon, even if a little bit more reluctantly, is accepting essentially Kubernetes as a standard. As final users, this is only good for us. There's no downside for the final users. The benefits of adopting Kubernetes for a multi-cloud strategy, of course, are leverage with your cloud vendor. I'm definitely seeing people that are talking to the cloud vendors and telling them, okay, you know, give me a good price, or I'll be able to move somewhere else, and being ready for the future, because you never know, you know, what's going to happen in the cloud dynamics, and adopting essentially an architectural approach that is a little bit more, that has a further layer of abstraction, will de-risk you essentially in the long term. All right. Lessons. First, and in my opinion, the most important lesson is microservices are all about people. If you are looking into Kubernetes, if you're looking into cloud native as a pure technology play, you're not going to be successful, because very much, you know, the goal of these technologies is empowering people, empowering development teams by rethinking the way the application is architectured, by splitting it into, you know, smaller modules that talk through very well-known and arranged APIs and orchestrated by an orchestrator like Kubernetes. So typically, a journey to Kubernetes, a journey to cloud native, starts with people. You need to make sure that you have the right organization and the right buy-in from the teams to work that way and to respect this philosophy. Otherwise, it's just a technology, and it won't be, you know, embraced by the organization, by the real users, and probably very likely it's going to just have, you know, like a niche utilization inside your organization. While when I'm seeing people that really start by thinking about the people first, thinking about essentially how what this means in terms of the organization, that's when these kind of initiatives, at least in my experience, I've seen them to be very successful, in some cases really, you know, expanding very quickly to the whole organization. Another lesson, it's a much more open world. So I was talking about cloud computing and about how it's been approached in a way that is very powerful, but pretty much, you know, vendor specific. So even on AWS, every single service is, you know, something like that is specific. Even the open source solutions that are offered by Amazon, they are then, you know, repackaged in a way to be specific for AWS. While Kubernetes and the Kubernetes ecosystem is really, really, and I think Google has done a great job there, you know, been designed from the beginning to be as open as possible. Which means, especially through the help of the CNCF, there's really sort of a stack. Each component of the stack is really, you know, like open, and it's really interesting. Even vendors like Sysdig are really rethinking their approach and approaching this in a way that is as open as possible. In particular, you know, our experience as Sysdig, for example, with Falco, which is runtime protection for Kubernetes, right? And of course, Sysdig offers, you know, commercial products for this. But we really thought that especially the security industry was approaching this in a way that was quite proprietary, you know, in terms of solutions. So we thought, why not going open source first? So even before Sysdig, actually quite before Sysdig had a commercial product for security for Kubernetes, we released Falco, initially as an experiment, and then, you know, starting gathering a community around it. And now Falco is part of the CNCF as a project that is part of this community. And it's really interesting how the CNCF is really pushing us to make this a real community, to avoid having an open source tool that is just, you know, like a vendor-backed open source tool, and wants to see, you know, like contributors from outside the company and all of that kind of stuff. And, you know, we're in the business of ideally making money around the Kubernetes community, but also, you know, as a vendor that makes money, we're very much in the business of trying to adopt an approach where the users can leverage our technology as part of the ecosystem and in a way that is totally open and also free. And this actually makes our product much better, because the community is really driving essentially where we're going with this project. By the way, this is the link of Falco. You can go and you can go take a look. It's a pretty nice, fun tool to use. The ecosystem, another lesson, is not only very much open, but also changing very fast. And this is clearly a challenge for many people, you know. I put together this slide that essentially shows a simplified evolution of cloud-native ecosystem in the last, let's say, 5 years, you know, 5, 6 years. From when Docker was announced at PyCon in 2013 to, you know, recent stuff like EKS, Istio, and so on. It's a lot of stuff. It's overwhelming. It's overwhelming for many people, you know, even people that are in the industry. You know, in this slide we have container runtimes, you know, multiple of them. Docker, Rocket, Cryo, and so on. We have operating systems to run containers, right? CoreOS, Atomic, you know, now Fedora is merging with CoreOS after the acquisition of the company CoreOS. You have orchestrators. Well, on this one, Kubernetes is clearly becoming the standard, you know, but it wasn't that clear even just 18 months ago, you know. Mesos and DCOS, Docker Swarm, and so on, you know. So even here, quite a bit of choice, right? You have cloud vendors, because now pretty much every cloud vendor supports Kubernetes, right? So I'm not even mentioning all of them, you know, but Google was the first one in 2015. Microsoft released AKS in 2017, and Amazon released EKS in 2018, right? You have service meshes that are the new thing, you know, very important, very powerful. But again, how many dimensions do you have? How many combinations and permutations of all of these components you have, you know? It can be confusing, it can be overwhelming, it can also be risky, you know, because in an ecosystem that moves so quickly, as a technical leader, you have to take your decisions. You sort of have to predict the future, you know? And if you don't do it in the correct way, you're losing time and you're losing money for your organization, right? So it's not trivial, you know, and it's overwhelming. I don't really have, you know, a big answer to that, rather than, you know, that's why we're here at KubeCon. You know, the only way and the best way to be able to take the right decisions for our company is try to be as informed as we can, right? Lesson, multi-cloud, at least based on what I'm seeing, and if you guys have a different experience, I'm very happy to learn from you, but for the moment, it's still largely a pipe dream. So ideally, when people design for multi-cloud, they design for something like this, right? I will have you know, footprints in all of the different clouds. I will also have a footprint on-prem, and then I will run applications in a way that is, you know, magically orchestrated, and pieces of this application can really run, you know, maybe a piece on AWS and a piece on Google, or, you know, a piece on on-prem and a piece on Azure. And the different services are magically orchestrated, right? So this is what people try to do. Nowadays, if you're advanced, you probably do something like this. So you're still using multiple clouds, but you're segregating each different application on a specific cloud without the ability to move it or to transition to something different. Very often because maybe you're still using some proprietary services in the cloud, or because, you know, your migration of your components doesn't work very well across clouds and so on. But you're still using multiple ones. But this is for advanced users. In the majority of the situations, I see people that are like, okay, I want to be prepared for this. I'm going to use Kubernetes, but for the moment, I'm doing it in a single place, you know, or maybe in two places, you know, maybe in my own data center and in AWS as a transition, and maybe I'm using Kubernetes as a way to start having, you know, consistency among the two, but I'm still using, you know, just one for the moment. Lesson, we're dealing with locusts. What does it mean? one of the ways that people often use to describe the transition from traditional, enterprise IT architectures to the cloud ones is we're going from pets to cattle, right? When you had your Solaris servers or your Oracle software, running on these big servers, typically you were treating these servers as a pet, right? You were buying the best servers. You were putting a lot of tools on them to make sure that they never go down. You were making sure that these servers were reliable data centers and so on. When you go to cloud, it's more like having a kettle of smaller instances that you can turn on and off more easily, and you essentially rent from the cloud provider, and you treat them, you put them after a load balancer, and you treat them as a group. And if one of these disappears, it's not a huge deal, right? Because you have mechanisms in place to deal with that. And you're just, organizing them like you can have an arbitrary number that can grow or can decrease. Well, my metaphor for moving from cloud instances and virtual machines to containers is now you have a swarm of locusts. They're small, they're very fast, they are everywhere. If you're not careful about how you treat them, they can do a big damage, right? And they're much quicker, So when you're dealing with cattle, with like a group of cows, you can still deal with the single one, because it's still important enough for you. When you're dealing with locusts, you're not dealing with a specific single one anymore. This is just a cloud of stuff that is moving very, very fast, and there's no way to focus on the single little entity here. It's just a waste of time, right? So, what does it mean? It means that first of all, yes, it's hard to deal with locusts, right? So essentially, we're moving from something like this. This is a very unartistic, simplified diagram of an application in the old age, right? Cache, web server, database, right? And in this case, essentially, what you were dealing, especially to run this in production, to secure these, to manage this, to have visibility on this, was relatively simple, right? Well, now you have something that looks more like this, right? You have a bunch of computing nodes, the gray boxes in this slide, and then you have, the containers running on them, and you have, the color coding is different colors. So just approaching these and just understanding, sometimes what's happening in your infrastructure can be challenging without doing sophisticated stuff like runtime protection and firewalling and all this kind of stuff. Just the basic thing of understanding what you have that is running, in some cases, can be challenging, right? So legacy tooling, I'm sorry to tell you, is not going to help you anymore. So storage, networking, security, visibility, it will be very hard to adapt what you are using today to the new world. So the unfortunate situation is that when you're moving to cloud native, you not only are picking an orchestrator, but you probably need to rethink essentially your tooling, the rest of your infrastructure. The good news is that the next generation of tools can actually be better. Why? Because locusts are closer to the code. So if we look again at a diagram like this, for example, I don't know, when you had to do, let's take, for example, application transaction monitoring, and application performance management. Traditionally, you buy tools like, I don't know, ADynamics, Dynatrace, or stuff like that to do that. And what these tools do essentially is they link to libraries inside your code that is running, in specific places, and they instrument this, and then they give you essentially insights on how your code works. But in order to do that, essentially, you need to go inside your application, because in a situation like this, there's really not a good way to get insights, for example, for the green box, without having to go inside and link some libraries or something like that. Well, in a situation like this, if you want to look at what the green stuff does, you have many more insertion points, right? because you have many more little components that are talking together. So it's very likely that you're able to get a good overview of the performance of like the green service without having to go inside your code and try to do your instrumentation from there. Same with security, you know. For example, I don't know, like communication, you know, network security. In a diagram like this one, you only have like, this is an example, but you only have 2 places where you can go and firewall things, right? While in a situation like this, yeah, it's more complicated, but you have much more granularity. You're much closer to essentially the real service when you do enforcement at the network layer. So based on that, my claim is that containers can be more manageable, and also container can be more secure. Typically, when people talk about transitioning to containers, transitioning to cloud native, one of the concerns is always security is going to decrease because containers are less secure than virtual machines, right? Containers are less isolated than virtual machines. I argue the opposite because yes, it's true. There's less isolation, but there's much more granularity in the way you can protect your applications. So if properly implemented with the proper philosophy, security can be not only as good, but can be better with containers. Last lesson, the journey to cloud native is definitely not easy, can be overwhelming, but it's absolutely worth it. If properly implemented, cloud native architectures benefit both the business and the developer. For the business, they will increase the innovation pace, they will reduce cost, and they will mitigate risk. And for the developers, they will be, you know, more infrastructure agnostic. They will create more like independency and more ownership, and will make essentially your software more reusable. So it's not easy, but it's well worth it. And that's it. Thank you very much.